What if the planet that has mesmerized humanity for centuries with its crimson hues could one day transform into a lush, green oasis teeming with life? This is not a scene from science fiction, but a vision grounded in the bold aspirations of science and technology. Welcome to a journey that spans the years 2030 to 2500, where we explore humanity's most ambitious project yet, terraforming Mars. Imagine the red sands of Mars warming under a thicker atmosphere, rivers carving through valleys, and forests thriving under a new sky. But how do we turn this seemingly impossible dream into reality? And why should we even attempt it? This video dives into the challenges we must overcome, the groundbreaking technologies we will develop, and the transformative visions that will guide us from the first human footsteps on Martian soil to the creation of a self-sustaining world that could one day rival Earth itself. From mining Martian resources to building massive ecosystems, each step represents not just a technical achievement, but also a testament to human ingenuity and resilience. The implications go far beyond Mars. They touch on the survival of our species, the expansion of our knowledge, and the enduring quest to explore the unknown. So, fasten your seatbelt as we unravel how humanity, with determination and innovation, could transform Mars from a barren rock to a thriving second home for future generations. Stay with us as this journey will change the way you see not just Mars, but the very essence of what humanity can achieve when we dare to dream beyond the stars. Now turning to the question of why we should terraform Mars, the reasons are as compelling as they are urgent. Earth's population is growing rapidly, and with it, the demand for resources is reaching unsustainable levels. From freshwater scarcity to the depletion of fossil fuels and vital minerals, our planet is facing a crisis that demands bold solutions. Climate change only adds to the urgency, with rising temperatures, extreme weather events, and sea levels threatening ecosystems and human livelihoods worldwide. As we grapple with these challenges, the idea of creating a backup plan for humanity becomes not just a visionary goal, but a necessity for long-term survival. Terraforming Mars offers such an opportunity. By transforming the red planet into a habitable world, we could secure a second home where humanity can continue to thrive even if Earth's environment becomes inhospitable. But beyond survival, there are deeper philosophical motivations that drive this ambition. Humanity has always been an explorer species, pushing boundaries and seeking to understand the unknown. Expanding to Mars and beyond allows us to carry this spirit into the stars, uniting nations and generations in the pursuit of knowledge and innovation. Colonizing another planet would also expand our understanding of life itself, challenging us to adapt and evolve in ways we cannot yet imagine. And let us not forget the scientific discoveries that such an endeavor would bring, unlocking secrets about Mars's history, its water, and perhaps even the possibility of ancient life. Each step we take toward terraforming Mars is not just about survival, but about becoming a truly interplanetary species, capable of shaping our destiny among the stars. Yet, as we move forward, the question remains, why Mars, and what makes it the best candidate for such a monumental task? Stay with us as we explore why this crimson world holds the key to humanity's greatest aspirations. Now turning to why Mars is considered the most practical option for terraforming compared to other celestial bodies. The reasons lie in its unique characteristics that make it more Earth-like than any other planet in our solar system. To start, Mars has polar ice caps made of water and carbon dioxide, offering a vital resource for creating an atmosphere, producing liquid water, and supporting future life forms. Its day length is strikingly similar to Earth's, lasting just over 24 hours, which means that the natural rhythms of human activity, such as work and rest cycles, could adapt more easily to life on Mars than on other planets. Furthermore, Mars has a manageable gravity level, about 38% of Earth's gravity, which is enough to maintain human muscle and bone strength while still making the logistical challenges of transporting goods and constructing habitats less demanding than on Earth. But while these similarities make Mars a promising candidate, there are also significant challenges that cannot be overlooked. One of the most pressing issues is the planet's lack of a thick atmosphere, which exposes its surface to harmful cosmic radiation and makes it impossible to retain heat. Without an atmosphere capable of trapping warmth, temperatures on Mars often plunge to extremes that would be uninhabitable for most life forms. Adding to the difficulty is the absence of a magnetic field, a critical feature that protects planets from solar wind and helps preserve their atmosphere over time. On Mars, this means that any newly introduced gases to thicken its atmosphere could gradually escape into space, posing a major obstacle to creating a stable and habitable environment. Yet, despite these challenges, Mars remains the most viable option for terraforming when compared to other planets or moons. Venus, for example, has a surface temperature hot enough to melt lead and an atmosphere thick with sulfuric acid, making it vastly more hostile. Similarly, while moons like Europa and Titan have captured the imagination of scientists, their environments pose even greater technological hurdles, such as extreme cold, lack of sunlight, or being trapped under thick layers of ice. Mars, in contrast, offers the right balance of potential and feasibility, with enough scientific understanding and available resources to serve as humanity's first stepping stone toward creating a new world. As we begin to envision the monumental task of transforming this red planet into a green oasis, the focus shifts to the progress that humanity is making right now. So, what does the vision of 2030 hold for our journey to Mars? Stay tuned as we explore the crucial first steps that will pave the way for this interplanetary dream. With the next phase of the journey in sight, humanity's progress in space exploration by the year 2030 sets the stage for the incredible transformations to come. Organizations like the National Aeronautics and Space Administration, Space Exploration Technologies Corporation, and the European Space Agency have been at the forefront of advancing our Mars missions, each making significant contributions to our understanding of the Red Planet. Robotic rovers like Perseverance and Curiosity have already paved the way, sending back invaluable data about Mars's geology, climate, and potential for past life, while new generations of these machines are being developed to take exploration even further. Among the most groundbreaking missions on the horizon are those focused on returning samples from Mars to Earth for the first time in human history. These missions aim to collect and safely bring back Martian soil and rock, allowing scientists to study them in ways that are not yet possible with spacecraft-based instruments. This achievement would mark a monumental leap in our ability to analyze Mars's resources and assess its habitability. Complementing these efforts are plans to deploy habitats designed to support the first human explorers. These habitats are being envisioned as self-sustaining, leveraging advanced technologies like in situ resource utilization to extract water and oxygen from Martian materials while providing protection from the harsh environment. Crucially, these missions are not just about exploration, they are laying the groundwork for what comes next. By 2030, humanity's presence on Mars will no longer be a distant dream but an emerging reality, supported by international collaboration and an unyielding drive to expand beyond our home planet. This moment in history will serve as the foundation for the technological leaps that will follow, bringing us closer to the audacious goal of transforming Mars into a world teeming with life. But how do we transition from exploration to creating a permanent human presence on the Red Planet? Stay tuned as we delve into the initial steps of building human settlements on Mars, a critical chapter in this interplanetary odyssey. With the next phase of the journey in sight, humanity stands on the threshold of establishing its first foothold on the Martian surface. The 2040s and 2050s mark the dawn of initial human settlements on Mars, a monumental step forward in our quest to become an interplanetary species. These settlements are envisioned as self-sustaining colonies designed to overcome the planet's harsh conditions and provide a safe haven for human life. To achieve this, pressurized domes and underground habitats will form the backbone of these early colonies, shielding inhabitants from extreme temperatures, radiation, and the thin atmosphere. Advanced construction technologies like three-dimensional printing will play a pivotal role in building these structures, using Martian regolith, the planet's native soil, as a raw material. This approach not only reduces the need for transporting building materials from Earth, but also demonstrates the ingenuity required to adapt to an alien world. Inside these habitats, hydroponic farming will take center stage as the primary means of growing food. By cultivating plants in nutrient-rich water instead of soil, these systems will maximize efficiency while minimizing resource needs. Hydroponic gardens will provide fresh produce, ensuring a reliable food supply while contributing to oxygen production and improving air quality within the living spaces. Complementing these efforts is the implementation of advanced recycling systems, which are crucial for creating a closed-loop environment. From water purification to waste conversion, these technologies will ensure that essential resources are reused and conserved to support the colony's needs. These early settlements represent more than just survival. They embody humanity's ability to innovate and thrive in the face of unprecedented challenges. They will serve as experimental hubs, providing critical data and insights needed to expand our presence on Mars. As pioneers set foot on this new frontier, they are not only carving out a space for humanity, but also paving the way for the long-term vision of transforming Mars into a world capable of sustaining life. This is only the beginning of an extraordinary journey, one that will grow in complexity and ambition as we strive to unlock the full potential of the Red Planet. But how can we harness the resources of Mars to fuel our efforts? The answer lies in learning to extract and utilize what the planet itself has to offer. Stay tuned as we explore the critical role of resource extraction in shaping the future of Mars settlement. Now turning to the critical task of extracting resources, this phase marks a significant leap in transforming Mars into a more habitable world. Scientists have pinpointed the planet's natural assets as the foundation for supporting human life and advancing terraforming efforts. One of the first priorities is accessing water, a resource vital for survival and various industrial processes. Mars's polar ice caps and underground reservoirs present promising sources of water. Advanced drilling technologies will be employed to tap into these reserves, while innovative methods such as heating the ice or capturing water vapor from the atmosphere could complement the extraction process. This water will not only sustain human consumption, but also serve as a key ingredient for generating oxygen and hydrogen, which can be used as rocket fuel. Moreover, the Martian soil, or regolith, is rich in minerals that could be instrumental in building infrastructure and creating essential materials directly on the planet. Mining operations will focus on extracting elements like iron, aluminum, and silicon, which can be used for construction and manufacturing. These resources, combined with three-dimensional printing technologies, will enable the creation of tools, machinery, and building components, reducing the dependency on shipments from Earth. Another critical resource is Mars's atmosphere, which, while thin and composed mostly of carbon dioxide, holds immense potential. By harnessing advanced chemical processing technologies, scientists aim to split carbon dioxide into carbon and oxygen. This oxygen can then be used to support breathing and fuel combustion, while the carbon might serve as a building block for other materials. These processes are not only critical for sustaining the colonies, but also play a pivotal role in laying the groundwork for atmospheric transformation. However, these resource extraction techniques are not without challenges. The harsh Martian environment, with its extreme cold, low air pressure, and high radiation levels, poses significant technical and logistical hurdles. Developing machinery and systems capable of operating efficiently under such conditions will require ingenuity and resilience. Additionally, ensuring the sustainability of these operations is vital to avoid depleting resources prematurely or causing unintended environmental impact. By learning to extract and utilize resources directly from Mars, humanity not only gains the ability to survive but also takes a crucial step toward making the Red Planet a self-sustaining extension of life. These efforts are the building blocks for a larger vision, one that leads us further into the ambitious journey of terraforming. But the transformation of Mars demands more than just raw materials. It requires a strategy to catalyze environmental change. Moving forward, we will explore the initial steps of terraforming and the revolutionary ideas that aim to breathe new life into the Red Planet. As the next challenge unfolds, the first steps of terraforming Mars center on introducing life forms that can endure the planet's harsh environment while beginning to transform it. Scientists propose starting with hardy microorganisms such as algae and bacteria that thrive in extreme conditions. These organisms have the potential to produce oxygen and enhance soil quality, laying the groundwork for a more hospitable environment. By introducing specific strains of bacteria capable of feeding on minerals in the regolith, oxygen could be released as a byproduct, while the soil itself becomes enriched with nutrients essential for supporting plant life in the future. Algae, on the other hand, could play a dual role. Not only can certain types of algae survive in cold, low-pressure environments, but they can also photosynthesize, converting carbon dioxide into oxygen. This process would contribute small but measurable amounts of oxygen to Mars's thin atmosphere, while also creating organic matter that could serve as the first step in building a sustainable ecosystem. These initial biological pioneers would represent a revolutionary leap in our ability to turn an otherwise barren terrain into one capable of supporting larger-scale life forms. Key to the success of this phase are breakthroughs in genetic engineering and synthetic biology. By modifying the DNA of these microorganisms, scientists can tailor them to withstand the unique challenges of Mars, such as higher radiation levels and limited water availability. These advancements allow researchers to create organisms that are not only resilient but also optimized for facilitating environmental change. The ability to design life tailored for Mars transforms terraforming from a distant dream into a carefully planned scientific venture. Scaling up these efforts would involve replicating and expanding these initial experiments across broader areas of the Martian surface. Innovative delivery systems, like drones equipped to disperse microorganisms over vast regions, could accelerate this process. The introduction of habitats that mimic Earth-like conditions on a small scale might also provide pockets of life to begin their transformation of the planet. While these first steps may seem modest, their significance cannot be overstated. They represent humanity's initial attempt to actively alter another planet's ecosystem. Every success in this phase brings us closer to a Mars that can sustain life, setting the stage for more ambitious efforts. As these early pioneers work to redefine the Martian environment, the path toward larger-scale atmospheric and climatic changes begins to take shape. This brings us to the next phase, the powerful role greenhouse gases could play in warming and thickening Mars's atmosphere. Moving forward, the methodical warming of Mars through the introduction of greenhouse gases emerges as a pivotal strategy in transforming the planet into a more Earth-like environment. Greenhouse gases, known for their ability to trap heat, can play a decisive role in raising the planet's average temperature and thickening its tenuous atmosphere. This process is not only fundamental for creating a more hospitable climate, but also essential for enabling the widespread presence of liquid water, a critical resource for sustaining life and further terraforming efforts. One of the most viable sources of greenhouse gases lies beneath Mars's surface and within its polar ice caps, where vast reserves of frozen carbon dioxide are locked away. By artificially heating these ice caps, carbon dioxide could be released directly into the atmosphere, contributing to the greenhouse effect. Technologies such as orbital mirrors that focus sunlight onto the ice caps or controlled explosions to release trapped gases have been proposed as potential methods to accelerate this process. These approaches leverage the planet's existing resources, making them both practical and efficient for the early stages of atmospheric transformation. Another intriguing possibility is the importation of greenhouse gases from Earth or other celestial bodies. For example, methane, a potent greenhouse gas, could be transported to Mars and dispersed into the atmosphere. While transporting gases from Earth poses significant logistical challenges, the idea of harvesting them from outer planet moons such as Titan offers a futuristic yet feasible solution. These efforts would be complemented by on-site production, where chemical reactions could be engineered to synthesize gases directly on Mars using available raw materials. The science behind this process revolves around the same principle that drives Earth's own climate, the greenhouse effect. Greenhouse gases allow sunlight to enter the atmosphere and reach the surface, but they prevent some of the heat from escaping back into space. This creates a warming effect that, on Mars, could elevate surface temperatures significantly over time. As the atmosphere thickens and warms, conditions would gradually shift, creating a foundation on which future steps in terraforming could build. This warming is far more than just a temperature increase. It represents an essential prerequisite for the next stages of transforming Mars. A thicker atmosphere not only helps to retain heat, but also protects the surface from harmful solar radiation, setting the stage for the gradual development of a stable, life-supporting climate. The introduction of greenhouse gases marks a transformative phase in humanity's vision for Mars, bridging the gap between its current barren state and the possibility of a thriving green world. With the atmosphere beginning to evolve, the next critical challenge comes into focus: the development of a magnetic shield to safeguard these fragile advancements and ensure Mars retains its newly formed atmosphere. As the next challenge unfolds, the development of a magnetic shield stands as a cornerstone in securing Mars's atmospheric evolution and broader terraforming efforts. Unlike Earth, Mars lacks a protective magnetic field, leaving its atmosphere vulnerable to being stripped away by solar winds. Without this safeguard, the gains from introducing greenhouse gases and thickening the atmosphere could be undone over time, jeopardizing the long-term viability of the planet as a habitable environment. One of the most innovative proposals involves placing an artificial magnetic shield at the L1 Lagrange point of Mars, a location in space where the gravitational forces of Mars and the Sun are balanced. By positioning the shield here, it could act as a barrier against solar winds, deflecting charged particles before they reach the planet. This concept essentially recreates the protective effect of Earth's magnetic field, shielding the atmosphere and allowing it to gradually stabilize and grow. The mechanics of such a shield would rely on generating a powerful magnetic field through advanced technologies, such as superconducting magnets powered by nuclear energy or other sustainable energy sources. These magnets would create a localized magnetic bubble that could extend over a vast area, intercepting and neutralizing the harmful effects of solar radiation. While this idea is still theoretical, ongoing advancements in magnetic field technology and energy production make it a plausible solution for future implementation. The importance of this shield cannot be overstated. Beyond preserving the atmosphere, it would create more favorable conditions on the surface by reducing radiation levels. This reduction is crucial not only for the safety of human settlers, but also for the survival of any introduced life forms, from microbes to eventual plant species. With lower radiation exposure, surface habitats could expand, and outdoor activities would become increasingly viable, paving the way for more extensive colonization and ecological development. Developing a magnetic shield represents one of the most ambitious yet essential steps in the journey to terraform Mars. It embodies humanity's ingenuity and determination to overcome the inherent challenges of transforming an alien world into a second home. Once this protective mechanism is in place, the focus can shift to further technological innovations that will drive the terraforming process forward. Among these, the role of artificial intelligence emerges as a key factor, offering unparalleled capabilities to manage and optimize the complexities of this interplanetary endeavor. With the next phase of the journey in sight, the spotlight turns to the groundbreaking technologies that will make terraforming Mars a reality. Among these, the advancements in nanotechnology hold immense promise. Nanotechnology could revolutionize the process by enabling the creation of materials specifically designed to withstand the harsh Martian environment. These materials could be used to construct habitats, infrastructure, and even equipment that are lighter, stronger, and more efficient than anything currently available. For example, nanoscale coatings might protect surfaces from radiation or extreme temperatures, while self-repairing nanomaterials could ensure the longevity of critical systems with minimal human intervention. Moving into biology, genetic engineering stands as a cornerstone of innovation for introducing life to Mars. Through precise modifications at the genetic level, scientists could tailor plants and microorganisms to endure the cold, radiation, and low atmospheric pressure of the Martian surface. Imagine plants capable of growing in soils enriched with Martian regolith or bacteria that could naturally produce oxygen by consuming the carbon dioxide in the atmosphere. These breakthroughs would not only support the initial stages of greening Mars, but also serve as essential building blocks for developing a self-sustaining ecosystem. Synthetic biology could even allow scientists to design entirely new life forms, specifically developed to thrive on Mars and contribute to its transformation. Equally transformative is the role of advanced artificial intelligence in managing the intricate complexities of a terraforming effort. Artificial intelligence could oversee everything from monitoring atmospheric changes to managing resources with unparalleled precision. For instance, artificial intelligence could optimize energy usage, automate construction tasks, and predict potential challenges before they arise. Advanced learning algorithms could analyze environmental data to continuously refine terraforming strategies, ensuring that every step taken maximizes efficiency and effectiveness. With its ability to process vast amounts of data in real time, artificial intelligence would act as an indispensable partner in navigating the immense scale of this endeavor. Sustainable energy solutions also take center stage in powering these ambitious efforts. Nuclear fusion, often referred to as the ultimate energy source, could provide the vast amounts of power necessary for large-scale terraforming operations. Fusion reactors, unlike their nuclear fission counterparts, produce minimal waste and have the potential to operate continuously, offering a nearly limitless energy supply. In addition, advanced solar power systems could harness the abundant sunlight on Mars to generate electricity, further diversifying and stabilizing energy sources. Technologies like space-based solar arrays or high-efficiency photovoltaic cells could play a crucial role in powering habitats, vehicles, and life support systems in an environmentally sustainable manner. Together, these futuristic technologies represent the collective brilliance of human innovation, paving the way for a future where transforming Mars is no longer a distant dream but an achievable reality. As these advancements take shape, the integration of such technologies will set the stage for the next pivotal steps in creating a world where life, both human and non-human, can flourish. With these tools in hand, the path forward leads to one of the most critical aspects of terraforming: the quest to create and sustain liquid water on the Martian surface. Moving forward, the role of artificial intelligence emerges as a cornerstone in addressing the complexities of terraforming Mars. Artificial intelligence systems hold the potential to transform the daunting scale of this effort into a manageable reality. One of their most critical applications would be the continuous monitoring of environmental changes. By deploying a network of artificial intelligence-powered sensors across the Martian surface, scientists could gather real-time data on temperature, atmospheric composition, and radiation levels. This data would then be analyzed to track the progress of terraforming and identify areas that require immediate attention or adjustment. Another transformative capability of artificial intelligence lies in resource allocation, ensuring optimal use of the limited materials and energy available on Mars. For instance, artificial intelligence could determine the most efficient allocation of energy between life support systems, construction tasks, and research activities. By constantly analyzing needs and supply, artificial intelligence could prevent waste and ensure the smooth functioning of Martian settlements. Current advancements in artificial intelligence, such as machine learning algorithms capable of identifying patterns and predicting outcomes, offer a glimpse into how these systems might evolve to meet the demands of such a massive undertaking. Automating construction projects represents yet another groundbreaking application of artificial intelligence. On a planet where human labor would be scarce and costly, artificial intelligence-powered robotics could handle the bulk of the workload. From assembling habitats and infrastructure to repairing damaged systems, these automated machines could operate tirelessly in the harsh Martian environment. For example, autonomous robots currently used in industries like mining and construction on Earth could be adapted and enhanced for Mars, equipped with the ability to work collaboratively, learn from tasks, and adapt to unforeseen challenges. Beyond these practical applications, artificial intelligence would also play a strategic role in refining long-term terraforming objectives. Advanced artificial intelligence systems could simulate thousands of environmental scenarios to identify the most effective strategies, factoring in variables like resource availability, potential risks, and environmental impact. This predictive capacity would allow scientists to make informed decisions at every stage of the process, significantly reducing the trial and error approach that would otherwise be necessary. As technologies continue to advance, artificial intelligence could eventually achieve a level of sophistication that allows it to operate with minimal human oversight, effectively becoming an intelligent steward of the Martian environment. This evolution would free human settlers to focus on innovation, exploration, and the development of Martian culture, while leaving the intricate and labor-intensive aspects of terraforming in the capable hands of artificial intelligence. With artificial intelligence as a powerful ally, the dream of turning Mars into a thriving, habitable world seems more achievable than ever, setting the stage for introducing one of the most vital elements for sustaining life, liquid water. With the next phase of the journey in sight, creating liquid water on Mars emerges as a pivotal challenge in the quest to sustain life and advance the terraforming process. Water, being the essence of life as we know it, is not only crucial for human survival but also for fostering ecosystems and enabling agriculture. Without it, the dream of transforming Mars into a habitable world would be incomplete. However, the process of creating and maintaining liquid water on a planet with Mars's current conditions is a daunting puzzle requiring innovative solutions and relentless determination. One potential method involves harnessing the power of sunlight using massive orbital mirrors to concentrate heat onto the Martian surface. These mirrors, strategically positioned in space, could direct intense beams of light onto the polar ice caps, gradually melting the ice and releasing water. This method, while feasible in theory, would require unprecedented engineering feats to construct and maintain the colossal mirrors in orbit. Another approach, albeit more controversial, includes the use of nuclear devices to generate heat through controlled detonations. By strategically placing these devices near ice-rich areas, scientists could rapidly unleash significant amounts of water. While effective in producing immediate results, this solution raises serious concerns about safety, ethics, and potential environmental damage. Even if the ice caps were successfully melted, the challenge does not end there. Mars's thin atmosphere and low atmospheric pressure make it incredibly difficult to keep water in liquid form. In these conditions, water would either freeze or evaporate almost instantly. To address this, scientists would need to simultaneously work on thickening the Martian atmosphere, possibly by releasing greenhouse gases to trap heat and increase surface pressure. This dual effort would create an environment capable of sustaining liquid water over long periods. Moreover, the distribution and storage of water across the planet would demand advanced technologies. Underground reservoirs or specially designed channels might be employed to prevent evaporation and ensure an even supply of water to different regions. The introduction of liquid water would not only support human activities but also set the stage for the gradual introduction of plant life, further accelerating the terraforming process. While the journey to creating liquid water on Mars is filled with scientific and ethical hurdles, each challenge offers an opportunity for groundbreaking discovery and innovation. As humanity ventures deeper into this monumental endeavor, the successful realization of stable liquid water would mark a turning point, paving the way for the next critical step, introducing life to the red planet. As the next challenge unfolds, introducing life to the red planet becomes a monumental step in the journey to transform Mars into a thriving world. This process would begin with the smallest and most resilient forms of life, microbes. These microscopic life forms, such as specially engineered bacteria or algae, would serve as pioneers in Mars's harsh environment. Their primary role would be to kick-start the production of oxygen, improve soil quality, and create a foundation for more complex ecosystems. By modifying these microbes through advancements in synthetic biology, scientists could design organisms capable of surviving Mars's extreme cold, high radiation levels, and thin atmosphere. These engineered life forms could, for example, absorb carbon dioxide from the Martian atmosphere and release oxygen, gradually enriching the planet's air composition. Moving forward, once microbial life takes hold and begins to alter the Martian environment, the next phase would involve introducing more complex organisms such as mosses and lichens. These are naturally hardy and could thrive in the evolving Martian conditions, further stabilizing the soil and contributing to the production of oxygen. Over time, as conditions improve, this process could extend to include larger plant species, particularly those genetically adapted to withstand the planet's unique challenges. These plants could eventually form the basis for Martian agriculture, allowing for sustainable food production and further enhancing the atmosphere. However, the introduction of terrestrial life to Mars presents significant challenges. The planet's environment is not naturally conducive to life, meaning gradual adjustments would need to be made to temperature, atmospheric pressure, and radiation levels. This necessitates innovative solutions such as protective habitats or controlled microenvironments, where plants and microbes can be nurtured until they are resilient enough to survive independently. Additionally, researchers must ensure that newly introduced organisms do not evolve in unpredictable ways, potentially disrupting the delicate ecological balance. Continuous monitoring and adjustments would be essential to guide the process and prevent unforeseen complications. The role of synthetic biology cannot be overstated in this transformative endeavor. Through genetic modifications, scientists could develop organisms uniquely suited to the Martian environment, enabling them to perform specific roles, such as breaking down rock into usable soil or efficiently recycling water and nutrients. These bioengineered organisms would essentially act as tools, accelerating the planet's transformation while ensuring sustainability at every stage. As the effort to introduce life progresses, each breakthrough would bring humanity one step closer to transforming Mars into a world capable of sustaining not just ecosystems, but eventually human civilizations. This phase would mark the beginning of an extraordinary partnership between humanity and the cosmos, as life begins to establish itself on a planet that has been barren for billions of years. With these initial steps complete, the next chapter in the journey reveals itself, envisioning the decades of Martian forests and their profound impact on the planet's evolution. With the next phase of the journey in sight, we step into the era of Martian forests spanning the years from 2100 to 2200. This transformative period envisions a Mars where trees and plants gradually take root, marking a monumental leap in the terraforming process. By this time, the air would have undergone significant enrichment, thanks to the groundwork laid by microbial life and hardy plants introduced earlier. The presence of trees with their extensive canopies and deep-rooted systems would not only amplify oxygen production, but also play a critical role in stabilizing the atmosphere. These forests would act as natural carbon sinks, absorbing carbon dioxide and releasing oxygen, making the air increasingly breathable over centuries. The introduction of Martian forests would also drastically improve soil quality. Tree roots would bind the soil together, preventing erosion caused by Mars's notorious dust storms. Decaying plant matter would enrich the ground, creating fertile conditions for further vegetation growth. Over time, this would establish a self-sustaining cycle of decomposition and nutrient recycling, essential for the planet's ecological stability. These changes would pave the way for larger, more diverse ecosystems to flourish, creating habitats that could support both plant and, eventually, animal life. This ambitious vision would rely heavily on groundbreaking advancements in technology and genetic engineering. Scientists would need to develop tree species capable of thriving in Mars's harsh conditions. These genetically engineered trees could, for example, possess traits that allow them to withstand freezing temperatures, grow in low-pressure environments, and tolerate high radiation levels. Additionally, such trees might have enhanced photosynthetic capabilities, enabling them to produce oxygen more efficiently than their earthly counterparts. Technological innovations such as automated planting systems and artificial intelligence-driven environmental monitoring networks would also play a pivotal role. These systems could ensure that trees are planted in optimal locations and that their growth is carefully tracked and adjusted as needed. Furthermore, controlled greenhouses might be used to nurture the first generation of trees, shielding them from Mars's challenges until they are robust enough to grow independently. The emergence of Martian forests would not only represent a major ecological milestone, but also a profound psychological and cultural shift for humanity. The sight of vast green expanses under Mars's pink skies would symbolize hope and resilience, reminding us of our ability to overcome even the most daunting challenges. As these forests take root and expand, they would provide the foundation for sustaining life on Mars, opening the door to even more ambitious possibilities. With this ecological transformation underway, the focus would shift to tackling the complexities of developing a truly self-sustaining ecosystem, ensuring that Mars continues its journey from a barren red planet to a thriving green world. As the next challenge unfolds, we delve into the complexities of creating a truly self-sustaining ecosystem on Mars. While the establishment of Martian forests would mark a significant milestone, achieving a balanced and enduring ecosystem involves far greater intricacies. Introducing diverse plant and animal species to Mars requires an exceptional understanding of ecological interactions. Each species must contribute to the stability of the environment, creating a system where every organism plays a vital role in nutrient cycles, energy transfers, and environmental maintenance. One of the primary challenges lies in carefully selecting which species to introduce. scientists would need to prioritize plants and animals that can adapt to Martian conditions while also ensuring they complement one another within the ecosystem. These organisms must be genetically engineered or biologically modified to survive the planet's low gravity, limited water supply, and high levels of radiation. For example, certain algae or fungi might be introduced alongside forest vegetation to aid in nutrient recycling and soil enrichment. Similarly, herbivorous species capable of surviving on genetically engineered Martian plants would play a critical role in maintaining vegetation balance, while their waste would contribute to soil fertilization. However, this delicate balance comes with the risk of unforeseen chain reactions. Introducing even a small number of species to a developing ecosystem could lead to the overpopulation of one species or the unintentional extinction of another. Such imbalances would disrupt the nutrient cycles and weaken the overall stability of the habitat. Monitoring and mitigating these risks would be an immense task, requiring advanced artificial intelligence systems to observe interactions, predict potential problems, and implement solutions. These systems could simulate various ecological scenarios to optimize the introduction and management of species. Another significant challenge is the extended timescale required for ecological stability. Unlike on Earth, where ecosystems have evolved over millions of years, Mars would need to compress this process into decades or centuries. This accelerated timeline adds pressure to ensure every element is carefully planned and executed. Factors like disease outbreaks, environmental changes, or invasive species could pose additional threats, further complicating the balancing act. Beyond the biological hurdles, maintaining long-term stability would also depend on how well human activities integrate with these ecosystems. Human settlements on Mars will inevitably interact with the environment, and designing colonies that minimize ecological disruption is critical. Waste management, resource extraction, and agricultural practices must align with the needs of the developing ecosystems to prevent unintended harm. Despite these challenges, creating a self-sustaining ecosystem on Mars is not just a scientific goal, but a profound statement about humanity's ability to harmonize with nature, even on an alien world. The eventual success of this endeavor would mean establishing a living, breathing Mars capable of supporting a wide variety of life forms. This achievement would represent a monumental step in transforming the planet into a thriving green world, while also providing us with invaluable insights into the fragility and resilience of ecosystems. These lessons could even help address ecological challenges back on Earth. As the foundations of a sustainable Martian ecosystem take shape, the journey presses forward, exploring how humanity would navigate the profound social and cultural implications of transforming an entire planet. With the next phase of the journey in sight, we turn our focus to the profound social and cultural implications of terraforming Mars. Transforming the red planet into a habitable world is not only a scientific and technological undertaking, but also a venture that would fundamentally reshape human society. One of the most immediate questions revolves around governance. How would humanity manage a new planet? Would Mars operate under international cooperation, led by a global coalition of nations, or would private companies and individual pioneers play a dominant role? The establishment of fair and inclusive governance on Mars would be critical, setting the foundation for laws, resource allocation, and the rights of both individuals and communities living on the planet. Preserving Martian heritage would also become an important cultural consideration. While Mars has no human history, it carries billions of years of geological and planetary history. Balancing the scientific value of Mars in its pristine state with the needs of human development will likely spark ethical debates. Should certain regions, such as Olympus Mons or Valles Marineris, be preserved as natural landmarks akin to Earth's national parks? These decisions could reflect humanity's values and priorities as we venture beyond Earth. the psychological effects of living on an entirely new planet would also be significant. Humans have evolved on Earth, and the experience of living under different skies amidst altered landscapes would profoundly affect our collective psyche. Residents of Mars might develop a unique sense of identity and belonging, shaped by their shared experiences of hardship, innovation, and collaboration in a challenging environment. Over time, this could lead to the emergence of a distinct Martian culture, complete with its own traditions, art, and philosophies. Such a culture could emphasize themes of resilience, adaptability, and a deep connection to the new environment. At the same time, ethical questions would arise around issues like equality and access. Who gets to live on Mars and who decides? The process of selecting individuals for migration could raise concerns about fairness and representation across socioeconomic, cultural, and national lines. Ensuring that Mars does not become a place of exclusivity or exploitation will be vital as humanity establishes its presence on another world. As we consider these social and cultural implications, it becomes clear that terraforming Mars is not merely about adapting the planet to support life. It is about imagining the kind of society we want to build and the legacy we wish to leave for future generations. Moving forward, the challenge will be to ensure that these considerations are not afterthoughts but central to the planning and execution of humanity's greatest endeavor. With these reflections in mind, we now explore the great transformation that could redefine Mars by the year 2200, envisioning a planet transformed by our collective efforts. With the next phase of the journey in sight, let us envision what Mars might become by the year 2200, a world transformed by centuries of human effort and ingenuity. By this time, the Martian atmosphere could be significantly thicker, providing a breathable environment in some regions, or at least conditions where humans could step outside with minimal life support. Progress in atmospheric development would have been driven by relentless scientific advancements, including the gradual release of greenhouse gases to raise surface temperatures and the introduction of genetically engineered organisms capable of producing oxygen. This transformation would create a sky no longer dominated solely by its original shades of rust, but now interspersed with hues of blue and green, signaling the presence of thriving ecosystems. Water, an essential component of life, could flow freely on the surface by 2200. Vast networks of lakes, rivers, and even small seas may stretch across the planet, fed by melted polar ice caps and subterranean reserves. Advanced water distribution systems designed to manage this precious resource efficiently would ensure its availability for human settlements, agriculture, and the emerging Martian environment. These developments would mark a monumental shift in how the planet functions, transitioning from a dry and barren landscape to one that supports freshwater systems critical for sustaining life as we know it. The growth of cities on Mars by this time would be equally remarkable. Sprawling urban centers, meticulously designed to integrate with the natural Martian surroundings, could flourish across the planet. These cities would likely feature sustainable architecture, powered by advanced renewable energy technologies such as nuclear fusion or enhanced solar energy systems. Farming communities, using innovative techniques like vertical farming and soil regeneration, could provide a stable food supply not only to Mars itself, but also as a resource for interplanetary trade with Earth. The urban and rural landscapes of Mars might merge harmoniously, with green spaces and forests interwoven with futuristic infrastructures, creating a balance between technological progress and environmental stewardship. By 2200, Martian society could be thriving, characterized by collaboration and interdependence both within the planet and between Mars and Earth. Trade routes might exchange unique Martian minerals and resources with Earth's goods and technologies, fostering economic prosperity for both worlds. The cultural and technological exchanges between the two planets would deepen their connection, making Mars an integral part of humanity's expanding presence in the universe. These achievements would stand as a testament to humanity's ability to dream big, work together, and overcome challenges to forge a new world. As we imagine this extraordinary transformation, one cannot help but marvel at the boundless human potential that could make such a future a reality. With these incredible advancements in mind, the journey toward transforming Mars would still face numerous obstacles. As we move forward, it is crucial to understand the setbacks that could arise in the process and the innovative solutions humanity will need to overcome them. As the next challenge unfolds, one cannot ignore the inevitable setbacks and obstacles that will emerge over the centuries-long process of terraforming Mars. Natural disasters such as massive dust storms could severely disrupt progress. These storms, which can engulf the planet for months, might damage infrastructure, reduce solar energy output, and compromise the stability of newly established ecosystems. To combat this, humanity would need to develop highly resilient materials and technology capable of withstanding the sheer force of Martian storms. For instance, advanced autonomous systems could ensure that critical equipment remains operational during these turbulent periods, while underground facilities could provide safe havens for human settlers and vital resources. Political conflicts might also arise, complicating the collaborative efforts required to terraform Mars. With multiple nations and organizations involved, disputes over governance, resource allocation, and territorial claims could threaten the unity necessary for such an ambitious endeavor. To address this, a robust and transparent framework for interplanetary cooperation would be essential. This might include international agreements that prioritize shared goals over individual interests, along with the establishment of governing councils made up of representatives from all participating entities. By promoting cooperation and equitable resource management, humanity could mitigate the risks of political divisions derailing progress. Unforeseen environmental changes on Mars could further challenge terraforming efforts. For example, the release of greenhouse gases might not behave as predicted, potentially leading to unbalanced warming or triggering unintended ecological consequences. To navigate these uncertainties, continuous monitoring and adaptive strategies will be critical. Advanced artificial intelligence systems could analyze real-time data to predict potential issues and propose immediate corrective actions. This level of flexibility would enable humans to adjust their approach dynamically, ensuring that progress remains on track despite unexpected challenges. Even with these setbacks, the resilience and ingenuity of humanity have repeatedly shown that obstacles are not insurmountable. Learning from past experiences on Earth, such as managing extreme weather events or resolving international disputes, will provide valuable lessons for addressing similar challenges on Mars. Each solution, whether technological, political, or ecological, would not only contribute to the success of terraforming Mars, but also enhance our ability to tackle complex global challenges on Earth. As these obstacles are met with determination and innovation, they serve as a reminder that the path to transforming Mars into a thriving, habitable world is not only a test of our technology, but also a testament to our collective resolve and adaptability. Now turning to the ethical debates surrounding the transformation of Mars, the question arises, do we have the moral right to alter an entire planet? On one hand, proponents argue that terraforming Mars represents a crucial step for the survival of humanity. As Earth's resources diminish and climate challenges worsen, creating a second home for future generations could be seen as not just an opportunity but an obligation. Supporters also highlight how the endeavor would expand human knowledge and foster innovations that could benefit our home planet. However, others raise valid concerns about the moral implications of such an undertaking. Mars, in its untouched state, is a unique geological and scientific treasure. By altering its surface and atmosphere, we risk erasing critical evidence of the planet's natural history or potential signs of past life, forever losing the opportunity to study it as it exists today. There is also the question of whether humanity should focus its efforts and resources on fixing Earth's problems first. critics argue that prioritizing Mars could divert attention from pressing global issues such as poverty, environmental degradation, and inequality, suggesting that we must first demonstrate the ability to care for our own planet before seeking to transform another. Furthermore, the act of reshaping an untouched world raises broader philosophical questions about humanity's role in the universe. Should we impose our will on a world that has existed for billions of years without us, or does that demonstrate a dangerous hubris? Balancing these arguments requires a thoughtful and inclusive dialogue where ethical considerations weigh as heavily as the technological and scientific possibilities. This conversation about the ethics of terraforming Mars not only reflects our aspirations but also challenges us to consider the responsibilities that come with such unprecedented power. Moving forward, we delve into the legal and governance frameworks that would be essential for terraforming Mars, a topic that brings its own set of complexities. Currently, treaties like the Outer Space Treaty, which was established decades ago, provide the foundation for international space law. This treaty clearly states that no celestial body, including Mars, can be claimed by any nation. While it emphasizes peaceful exploration and international cooperation, it was created at a time when the concept of terraforming and large-scale colonization seemed like science fiction. Its limitations become apparent when considering the future realities of transforming an entire planet. For example, who would oversee and regulate such a monumental endeavor? Would Mars fall under the jurisdiction of a single entity, or would it require a completely new governance model? Some suggest that international collaboration, similar to how we manage global institutions like the United Nations, could provide a framework for fairness and shared responsibilities. This approach would ensure that Mars remains a collective effort representing all of humanity, rather than a playground for the most powerful countries or private entities. However, others argue that corporate involvement is inevitable as private companies, particularly those leading innovations in space exploration, will likely drive the majority of the terraforming efforts. If corporations play a central role, questions arise about accountability and profit motives. How do we ensure that the interests of humanity as a whole are prioritized over shareholder returns? And if private companies operate on Mars, what laws will they be subject to? An alternative vision considers the possibility of Martian self-rule, where Mars gradually develops its own independent governance as a distinct society. This would pose fascinating challenges in creating fair and functional systems of law, economics, and resource management in an entirely new environment. How would the settlers of Mars define their own identity, and how would they balance autonomy with continued ties to Earth? As humanity moves closer to making Mars an inhabited world, developing clear, equitable, and forward-thinking legal structures will become not just important but essential. This task demands global collaboration, transparency, and innovation to ensure that Mars truly represents an opportunity not just for survival, but also for shared progress and justice. With the next phase of the journey in sight, let us explore the role of education and global collaboration in turning the dream of terraforming Mars into a reality. The challenges of transforming the red planet into a habitable world are immense, requiring not only scientific breakthroughs but also a collective understanding and commitment from humanity as a whole. Education plays a pivotal role in this endeavor. By informing people about the scientific, ethical, and logistical aspects of terraforming, we can foster a shared sense of purpose and responsibility. Imagine a generation inspired by the possibilities of space exploration, equipped with the knowledge and skills needed to contribute to one of humanity's greatest undertakings. From early education that nurtures curiosity about the cosmos to advanced research programs focused on planetary science and engineering, building a global pool of expertise is essential. Beyond education, global collaboration will serve as the cornerstone of Mars's transformation. No single nation or organization can shoulder the immense financial, technological, and intellectual demands of terraforming alone. Governments, private companies, and international organizations must work together to pool resources, share innovations, and align efforts. Consider how international partnerships in projects like the International Space Station have shown us the power of cooperation in achieving the extraordinary. Similarly, a united approach to Mars could prevent competition and conflict, ensuring that the benefits of this monumental task are shared by all of humanity. Private companies will undoubtedly play a significant role, bringing their entrepreneurial energy and technical advancements to the table. However, it is through partnerships between these corporations and public institutions that we can strike a balance between ambition and accountability. With clear regulations and open collaboration, we can ensure that Mars's development serves the broader interests of humanity rather than narrow, profit-driven goals. International organizations could act as mediators and coordinators, ensuring that all voices are heard, from developed nations to those with fewer resources but equal stakes in humanity's shared future. The success of terraforming Mars depends on our ability to think beyond borders, fostering a shared vision of progress that unites rather than divides. As we educate and collaborate, we lay the foundation for a future where the transformation of Mars becomes not just a scientific achievement, but a testament to humanity's ability to work together for the common good. With the next phase of the journey in sight, let us step into the era of the Green Mars Initiative as humanity's relentless efforts finally begin to bear fruit. By the year 2300, Mars will no longer be defined solely by its crimson sands and barren landscapes. Instead, patches of green will emerge, symbolizing a profound transformation. Advanced technologies will have enabled the creation of vast forests, flowing rivers, and shimmering lakes, reshaping Mars into a planet that feels increasingly Earth-like. These forests will not only play a crucial role in oxygen production, but also stabilize the soil and create microclimates that support a broader range of life. Imagine towering trees engineered through genetic advancements, thriving in the thin Martian atmosphere while absorbing carbon dioxide and releasing life-sustaining oxygen. Rivers will carve through valleys, fed by carefully managed water systems sourced from melted polar ice caps and underground aquifers. These water systems will be maintained through innovations in hydrology that prevent evaporation in the low-pressure environment of Mars. Lakes will become reservoirs of life, supporting ecosystems of algae and aquatic plants specifically adapted to Martian conditions. This transformation will be made possible by breakthroughs in fields such as genetic engineering, climate science, and sustainable energy. Technologies like self-sustaining fusion reactors and advanced solar power systems will provide the energy needed to maintain and expand these ecosystems. Massive atmospheric processors will work tirelessly to thicken the Martian atmosphere, gradually raising temperatures and creating conditions suitable for liquid water to exist on the surface. This era will not just be marked by scientific achievement, but also by the resilience and vision of the human spirit. It will represent a triumph over challenges that once seemed insurmountable, as humanity continues its journey to make Mars not only habitable but vibrant with life. Moving forward, this vision of Green Mars will inspire generations, reminding us that even the most distant dreams can be brought to life through innovation, collaboration, and determination. As the transformation continues, the potential for a truly Earth-like Mars becomes a tangible goal, setting the stage for the next extraordinary chapter in this shared human endeavor. With the next phase of the journey in sight, let us explore the remarkable vision of Martian cities in the 2400s, where humanity's ingenuity will shape a new form of civilization. These cities will emerge as sprawling hubs of life, blending eco-friendly architecture with advanced technologies to create environments that not only sustain human life but also celebrate harmony with the transformed Martian landscape. Imagine towering structures designed to maximize energy efficiency, constructed using Martian materials through innovative techniques such as three-dimensional printing. These buildings will be equipped with systems that recycle air, water, and waste, ensuring a closed-loop sustainability that aligns with the planet's unique challenges. The architecture itself will adapt to Mars's conditions, with insulated habitats that regulate temperature and shield residents from radiation, while large transparent domes will offer breathtaking views of the planet's green transformation. Energy will flow seamlessly through these cities, powered by cutting-edge solutions such as fusion reactors and next-generation solar arrays that thrive under the Martian sun. Beneath the streets, intricate networks of tunnels and transportation systems will connect essential facilities, protecting them from Mars's harsher elements. Green spaces will weave through every corner, with vertical gardens and oxygen-producing plants becoming integral parts of urban design. These living structures will not only sustain life but also foster a sense of community and connection to nature. In these cities, the integration of resource cultivation will redefine urban living. Urban farms will flourish, producing food with minimal water and maximum efficiency, while artificial intelligence will oversee resource management to ensure balance and prevent waste. Technological and cultural hubs will emerge, drawing scientists, engineers, and artists to collaborate and innovate for a brighter shared future. Education, healthcare, and governance will function within systems designed to meet the specific needs of Martian residents, preparing them for the unique challenges and possibilities of life on another planet. These cities will become beacons of human resilience and creativity, serving as prototypes for future extraterrestrial settlements on moons and planets beyond Mars. They will demonstrate how humanity can not only survive but thrive in unfamiliar worlds, forging new paths in our quest to explore and expand the boundaries of existence. As these cities grow and prosper, they will symbolize the culmination of centuries of determination, a living testament to humanity's ability to turn imagination into reality. Moving forward, they will pave the way for the next great chapter in this extraordinary journey to redefine what it means to call a planet home. Now turning to the future of interplanetary trade and tourism, imagine a thriving exchange of goods and experiences between Earth and a transformed Mars. As the red planet becomes increasingly habitable, unique opportunities will emerge for the flow of resources and culture across the solar system. Martian minerals, rich with elements that are rare or depleted on Earth, could revolutionize industries ranging from electronics to construction back home. These materials, extracted and refined with advanced technologies, would become valuable commodities in a growing interplanetary economy. In return, Earth could supply Mars with specialized goods that leverage its abundant resources and manufacturing capabilities. Luxury items, cultural artifacts, and advanced technologies crafted on Earth would be highly sought after by Martian residents, fostering a dynamic exchange of value. Beyond the tangible trading of resources, tourism will play a pivotal role in shaping the relationship between the two planets. A terraformed Mars, with its green valleys, flowing rivers, and sprawling forests, would evolve into a must-visit destination for adventurers and explorers. Imagine standing on the edge of a Martian canyon, gazing at landscapes that are both alien and eerily familiar, or walking beneath the domed cities that stand as monuments to human ingenuity. Travel between Earth and Mars will become a spectacle in itself, with advanced spacecraft designed to offer comfort and breathtaking views of the Martian surface as they approach. Luxurious space hotels may orbit Mars, providing visitors with a once-in-a-lifetime experience of gazing down at the resplendent green planet below. Tourism could also catalyze cultural exchange, as Earth visitors bring their perspectives and traditions to Mars while returning home with newfound appreciation for interplanetary innovation and cooperation. The economic implications of this trade and tourism ecosystem could be profound, fueling industries on both planets and inspiring further advancements in space travel and planetary development. As Mars continues to evolve from a barren frontier into a thriving world, the connection between Earth and Mars will not only redefine commerce and exploration, but also strengthen the shared identity of humanity as a spacefaring species. With these possibilities in mind, the seeds of interplanetary trade and tourism exemplify humanity's ability to innovate and connect across unimaginable distances. As the journey continues, we look to the wider implications of these advancements, envisioning how the technologies developed for Mars could transform life on Earth itself. Moving forward, let us explore how the groundbreaking technologies developed for terraforming Mars could profoundly impact life on Earth. The challenges of creating a habitable environment on a distant planet demand revolutionary innovations, many of which hold immense potential to address pressing global issues here at home. For instance, advancements in climate control technologies designed to warm and stabilize Mars's atmosphere could be adapted to combat climate change on Earth. Imagine precise systems capable of regulating greenhouse gases or repairing ozone layers, providing new tools to restore balance to our planet's struggling ecosystems. Similarly, breakthroughs in renewable energy driven by the need for sustainable power sources on Mars could revolutionize energy production on Earth. From highly efficient solar arrays to compact nuclear fusion reactors, these innovations would offer cleaner, more reliable alternatives to fossil fuels, reducing our carbon footprint and ensuring energy security for generations to come. Resource management technologies essential for survival on Mars could also transform Earth's industries. Advanced recycling systems capable of creating closed-loop environments would drastically reduce waste and conserve resources. Methods developed to extract water and minerals from Mars's harsh terrain could be applied to remote or inaccessible regions on Earth, securing vital supplies for communities in need. Additionally, the practice of growing food in controlled environments, perfected in Martian greenhouses, could revolutionize agriculture by enabling year-round crop production in urban areas or arid climates, significantly enhancing food security. Beyond the technological benefits, the ethical and collaborative frameworks established during the terraforming process would inspire new approaches to solving Earth's challenges. The spirit of innovation and cooperation required to transform Mars demonstrates that humanity's ingenuity knows no bounds. As these technologies migrate back to Earth, they serve as a reminder that the pursuit of the extraordinary can yield solutions to even the most ordinary of problems. With the promise of these advancements, we now turn our attention to the human element of this journey, envisioning how life on Mars could shape the very nature of human evolution and identity. With the next phase of the journey in sight, let us delve into the fascinating question of how life on Mars could redefine the very essence of what it means to be human. As settlers adapt to Mars's unique environment, profound physiological transformations are likely to occur. The planet's lower gravity, at just over 1/3 of Earth's, would reduce pressure on muscles and bones, potentially leading to a gradual decrease in bone density and muscle mass over generations. This raises the possibility of taller, more slender physiques becoming a characteristic of Martian-born humans. However, this adaptation might also require medical advancements to counteract the risks of frailty or other complications. Beyond gravity, the higher exposure to cosmic radiation on Mars could drive significant changes. Without a protective magnetic field like Earth's, settlers would need advanced shielding technologies to minimize radiation exposure, but long-term effects might still include genetic mutations. This could result in either harmful conditions or potentially advantageous traits becoming part of the Martian human genome, emphasizing the critical need for scientific monitoring and genetic screening in these environments. Physiological differences may only be the beginning, as cultural evolution could forge a distinct Martian identity over time. the challenges of adapting to a new world would likely foster a strong sense of unity and resilience among settlers, shaping values and social structures in ways never seen before on Earth. Limited resources and isolated conditions could encourage a culture rooted in sustainability, resourcefulness, and collaboration. Languages, traditions, and even artistic expressions may transform to reflect the stark and unique Martian landscape. Through shared experiences, Martian settlers could develop a collective identity that sets them apart from their Earth-bound counterparts. Over generations, these physical and cultural adaptations might establish Martians as a truly separate branch of humanity, with their own norms and ways of life. As we explore these possibilities, one thing becomes clear. Humanity's journey to Mars is not just about crossing space, but also about crossing the boundaries of who we are and who we can become. Now, as we expand this vision of our future, let us turn our thoughts to what lies even further beyond, a glimpse into how Mars's transformation could become a springboard for exploring and terraforming other celestial bodies. With the next phase of the journey in sight, let us explore how humanity's success in transforming Mars could open the door to even greater cosmic aspirations. If Mars becomes a thriving, Earth-like planet, this accomplishment would not only demonstrate our technological prowess, but also provide a crucial template for future interplanetary ventures. The knowledge gained from terraforming Mars, such as creating sustainable ecosystems, managing atmospheric conditions, and mitigating the effects of radiation, could be directly applied to challenges posed by other celestial bodies. Venus, often referred to as Earth's twin due to its similar size and composition, presents an intriguing possibility. Its extremely dense atmosphere and scorching surface temperatures might initially seem insurmountable, but the potential for deploying floating cities or initiating atmospheric cooling could transform Venus into a habitable world over time. Similarly, the icy moons of the solar system, like Europa and Titan, hold immense promise. Europa, with its vast subsurface ocean, could harbor the necessary ingredients for supporting life, while Titan's dense atmosphere and hydrocarbon lakes offer unique opportunities for colonization and resource utilization. These environments, though hostile by Earth standards, represent unparalleled opportunities for human ingenuity to thrive. Mars, as our first terraforming success, would serve as the ultimate stepping stone, providing both the technological foundation and the psychological confidence to venture further into the cosmos. Beyond practical advancements, the cultural and philosophical implications of expanding humanity's reach to other worlds are profound. Each new frontier would challenge us to rethink our relationship with the universe and our role within it. This grand vision of interplanetary exploration is no longer confined to the realm of science fiction. It lies within the reach of future generations, driven by the same spirit of innovation and perseverance that is transforming Mars today. As we contemplate the vast possibilities of a multi-planetary existence, let us now turn our thoughts to the culmination of this extraordinary journey. The dream of a fully transformed Mars by the year 2500, a world reborn as habitable and vibrant as our own Earth. As the sun rises on the final chapter of this monumental journey, the year 2500 reveals a Mars transformed beyond imagination. After centuries of unwavering effort, the red planet now stands as a verdant, thriving world, mirroring the life-sustaining qualities of Earth. A stable atmosphere, rich in oxygen, blankets the surface, shielding it from radiation and retaining warmth, while expansive forests, grasslands, and winding rivers spread across the landscape, painting a picture of resilience and renewal. Ecosystems have flourished, with diverse plant and animal life coexisting in delicate harmony, a testament to humanity's ability to nurture life in even the most unforgiving environments. Advanced cities dot the Martian terrain, blending seamlessly with the natural surroundings. These self-sustaining communities thrive on renewable energy and innovative technologies, reflecting the culmination of human ingenuity. People walk beneath clear skies, breathe unassisted, and cultivate Martian soil to support farms that provide abundant food for both residents and future explorers. This is no longer a distant red world, but a second Earth in every meaningful sense. The cultural impact of Mars's transformation is equally profound. A distinct Martian identity has taken shape, rooted in the values of innovation, collaboration, and perseverance that brought humanity to this point. The society on Mars serves as a beacon of hope, proving that challenges, no matter how immense, can be overcome with unity and determination. The success of terraforming Mars serves as a long-term legacy for humankind, offering insights into environmental stewardship, resilience, and the limitless potential of advanced science and technology. More than just a second home, Mars stands as a monument to humanity's unyielding spirit to dream, create, and thrive beyond the boundaries of Earth. And with this incredible achievement, the door remains wide open for humanity to continue its exploration and transformation of the cosmos, an endless path illuminated by the green world that was once a red desert. Now turning to the conclusion of this extraordinary journey, it is impossible not to marvel at the transformation of Mars from 2030 to the year 2500. What began as a daring dream to shape a barren, red desert into a thriving, green world became a testament to humanity's resilience and boundless creativity. Along the way, we faced monumental challenges: thin atmospheres, harsh radiation, and the absence of liquid water. But with each obstacle, science and determination unlocked new solutions. From the first human settlements in pressurized habitats to the bold introduction of life forms, and from constructing artificial magnetic shields to creating liquid water and sprawling Martian forests, every step was a giant leap forward. Tremendous breakthroughs in technologies like genetic engineering, artificial intelligence, and renewable energy not only transformed Mars but also gifted Earth with innovations that could solve its own pressing challenges. Together, these milestones reflect the extraordinary timeline of human progress and the sheer tenacity required to transform dreams into reality. Yet, beyond the scientific and technological achievements, this journey also reshaped the very idea of what it means to be human. It proved that with unity, ingenuity, and vision, even the most daunting frontiers could become opportunities for growth and wonder. As we look to the cosmos, Mars, now a green world teeming with life, stands as a beacon of hope, a symbol that our greatest limitations exist only in our mind. It invites us to continue dreaming, creating, and exploring. Now, we turn to you. Do you believe terraforming Mars is a dream worth pursuing? Share your thoughts below, and don't forget to like this video, subscribe to the channel, and hit the notification bell to join us for more thrilling explorations of humanity's future. Together, let's keep imagining what lies beyond.